Newton's clockwork universe focused on the material world and the material objects through gravity, the force of gravity influencing and changing the things around them. Well, in the middle of the 19th century, around 1850, things began to change where attention wasn't on the material world and how that affects things around it, but the space itself, the energy fields around the material objects. Michael Faraday was one of the first to begin proposing the idea of what's often called field theory. And it comes from a theological understanding that God could speak power into existence around centers. And so there would be a field of force, a field of power around something that would be a conduit for force to be transmitted. And so that provided explanations for things like electrical fields. When you rub your socked feet on the carpet and then you touch your little sister or brother's ear and you see the electrical bolt that shoots from your fingertip to their ear, that is an electrical field that's coming from your finger to their ear. Also magnetic fields around magnets and the gravitational fields that develop around matter. It was seen as individual force fields around things. But the key to field theory wasn't the individual fields, that was understood, but explaining phenomenon as a combination or an overlapping of those particular force fields. And many of the more popular theories that we have today grew out of that field theory phenomenon, such as light. When we see the light around us, not just the visible light we see with our eyes, but infrared and ultraviolet, X-rays, gamma rays, radio waves, all those phenomena are interpreted within electromagnetic theory, that it's an electrical field and a magnetic field that overlap, and the phenomenon that occurs in the overlapping or the combining of those two fields produces this phenomenon. Also, Einstein's concept of space-time is an overlapping of two fields, field of space and the field of time. And that's led to a belief among many modern-day physicists that there could be something called a unified field theory, where these different phenomena become associated with each other. For instance, the fundamental forces that scientists speak of, gravity, electromagnetism, strong bonding forces, and weak bonding forces, and the nucleus of the atom, that these are somehow the same type of phenomenon. And whenever they're raised to particular energy levels, they will unite. And so sometimes this is called unified field theory, or the fact that we could unify them all, the grand unified field theory, where even elementary particles, protons, neutrons, and subatomic particles, the quarks, quirks, muons, leptons, gluons, all of those would somehow be combined within this particular concept of a grand unified single field. But anyway, that seems to be the future, moving away from the mechanical view of Newton, where matter is active and space is passive, to a field theory of Einstein, where space is actually active and matter is passive and moved by the energy around it. In some ways, to see space as active and influencing matter, we're actually going back to the Aristotelian concept of the doctrine of natural place, where there's something about space itself that would move objects into the place where they're supposed to be.